Nothing happened.
That's Gerardo. He's very needy. Okay, there you go.
Good? We're rolling? Alright. First of all, welcome North Central students. My name is Mr. Link. If I haven't had to work with you, you get to be working with all the great students in this class. Just stay away from this boy. Luckily you're across the city. Okay, but I would like to say congrats. You finished your AP Calc exam. You finished your AP English exam. Some of us took 3 exams, AP exams in 2 days. Who were those AP French students? You did that exam too?
Have the energy to raise their hands.
Yeah, seriously though, like you should be proud. You guys have worked a lot for this AP exam. These last few weeks, I've been pushing you hard. And this has been preparation for 9 months. Like 9 months we've been working on this material. You guys have worked really hard this year. And I've been working with you since last year as well. Like really, no matter what happens on the exam, no matter what your score is, you should be proud of the work you put in. Like my mom, what she always told me in a course was, she wouldn't get mad at me as long as I worked hard, and she was proud of me for the work I put in. It doesn't matter what score I got. So, you should feel that way about yourself.
In the DeRozier home, it was a different message. The message was, if you don't win, don't come home.
Did you win?
Oh, Lord, look at
Alright, so now we are in life, yes, post AP Calculus exam. Just make sure you guys write down what your homework is tonight.
Good one.
Can't read.
It says JK.
Oh.
So yes, you no longer have homework in this class. You no longer have homework in this class.
I do.
Well, except for those who are missing homework. Yeah. So how it's going to work is, over the next few days, we're going to do some math that I think is pretty cool. I think it should be enjoyable. The first grade enjoyed it. It's not high stakes. You're not going to be tested on it. But today we're doing something called Pascal's triangle. Tomorrow we'll do it too. Monday and Tuesday, tomorrow there will be color. Monday and Tuesday we'll do matrices, and then after that we're going to watch a pretty cool movie called Stand and Deliver. I was just about to say that. Thank you. So that'll be it. And starting Monday, for those who are missing homework, which is a good amount of us, I will be asking you to do the homework in class. That way you can, because I want those missing assignments in, and that way you can get it done during the school day. Hopefully get those all done without having to do any extra at home. Alright, so I do want to collect those blue sheets from you. It's in your locker. Do you want to go get it? If it's at home, bring it tomorrow. Or else I'm just not counting signatures. What? I thought you mouthed something else. Am I owing signatures to people? I haven't saved. Still counts. It's a signature. For tutorials? Wait, names. Guys, make sure your name is on top. A lot of people don't have their name on it. Just make sure your name is on top. Okay. You guys are good. Huh? I mean, I have it saved. What is it?
When you put your whole mouth on there and then the water goes back in there.
You crack it?
Yeah. Stuff like you behind your
Because the H is out.
Like,
The
I
H.
don't know, I can go back in
So
there.
you have to do. But it was
But then you found it, and then you just find it. So you don't have it, you can
Well,
have it
go
recorded.
ahead. Okay, take out. We did it.
That's by far.
Either it means
And then I went again today, so I want to
No, you
no,
don't.
we do it.
for the vlog. I had to Chelsea Velasquez.
All right, if I can have everyone's attention up at the front. All right, so these next 4 days, we will be doing math, and I do just want to set some expectations. I do think this will be enjoyable, but I do expect that you guys are actually working through class and staying engaged, because that will make it an enjoyable experience for you guys. You won't have homework. I'm just asking for 50 minutes of working through this material. So let's get started. Today we are working on something called the Pascal's triangle. Who's seen this before? Has anyone seen this before? No? Yeah? And Nelson, first period, said, yeah, I've seen this. It looks like a beehive. So this is one of the most famous figures in math because there's just a lot of really cool patterns with the numbers, probably more than I even know. And that's what we're going to start looking at today. So I'm going to give you guys 5 minutes. I just want you with your partners or anyone else in the room, write down as many patterns as you can notice in this triangle. Trust me, there are a lot. As many as you know. Patterns. What is going on with those numbers? I have lifesavers for every pattern that someone notices.
Why you red?
How many?
Why you blushing?
1, 2, 3,
In the camera.
4, 5, and then count. There's probably way more than I know.
Oh, what patterns do you
Put the go here.
Jonathan.
Oh, look, I see.
Alright, Jonathan. Hurry up.
3 plus 3 is 6. You can also say 1.
Whack.
12 plus 7 is...
You guys are both the patterns you said is good. Are good. That one's good too. What do you guys notice?
We're the same name. How does that even make any sense?
Like on both sides? Yeah. Is that just at the bottom?
Oh, look.
So there's a word for that?
This is, I see.
Y'all are not together.
Because 1 plus 4 is 5. 1 plus 5 is 6. 1 plus 6 is 7. And then 2 plus 3. Oh, wait.
Oh, so it's 1 plus 2 is 3, 1 plus 2 is 4,
Yeah. And then you continue going down. 1, 2, 3, 6. 1, 2, 6, 10. 1 point 10, 16. And then you just keep on going like that. You go down and then you go down. Reverse? No. Then 1 plus 6. Yeah.
And I heard you explaining.
So it adds.
Oh, the whole thing is in the bottom part.
Yeah, right.
Alright, and if you guys are looking for another pattern,
plus 3 is 6 plus 4.
Try adding up the total in each row. There's something that goes on there too. I'm sure how many lifesavers I
More.
It's times 2, 1 times 2, 2 times 2, 4. Okay, so wait, mix
It's not just 15.
Yep. That's how you should explain it. You can take it now. You're just Yep. All right, guys. Let's talk about it. So, I heard a lot of conversations going around, but now I want to talk about this full group. North Central guys, sorry I can't call on you. I'm sure you noticed some great things. All right, let's see. What patterns do we notice? I'll take some hands, and I've got some candies. Chelsea.
each of the rows sum multiplies by 2.
So the sum of the first row is 1, sum of the second row is 2, 4, then 8, then 16, and you notice that
Multiplies by
that sum is multiplied by 2. Caramel or Lifesaver?
2.
All right, what else? Gerardo.
The numbers on the middle add up and they create the number at the bottom.
So I think you see it, but I want you to be a little more specific.
Can I show?
Come up here.
It's better than I can.
And guys, this is Mr. Cabrera, the new calculus teacher, future calculus teacher.
Say hi. Like this. These two create this. If you add them, so 3 plus 3 equals 10, 10 plus 10 equals 20, so on.
Does that only work in the middle?
No.
Yes.
No.
Well, that's the only.
No, you can
Look,
like
anyone can do it. Does it look over here?
Oh, right here, right here.
It works everywhere, everywhere.
What's your name?
Thank you. You can use the rag. All right. What else?
Go G Money.
Noemi. Go.
If you like split it on the middle, like it, if you flip it, it's the same number.
Ah, there's a word for that. Right, if you go down the middle, it's the same numbers on both sides. Symmetrical. Lifesaver or caramel. All right, what else? Anything else? No? Jessica?
That's the new teacher too?
What's her name?
Mrs. Henderson.
This is Miss Henderson. This is what you were saying. Yep. See what she's saying? 1 to 3 is plus 2, 3 to 6 is plus 3, 6 to 10 is plus 4. Anything else? Crystal.
You go down the row, you add them and then go down, like down right. Like 1 and 1 equals 3. I don't know.
Wait, I'm not totally following you here.
Like 1 plus 1 is 2 and then 1 plus 2 is 3. Like,
Like this?
yes.
Yeah, and that's kind of using the, like 3 plus 1 is 4, 4 plus 1 is 5. Yeah, that's using what Gerardo was telling us. Caramel or Lifesaver?
Caramel.
Right, you're showing, you're doing the 2 numbers on top equal to 1 below. Any other patterns? Jose. Oh, we all like to come up here and teach.
Is there any more lectures?
Yes.
Okay, good. So that 1 plus 2 is 3, or 1 plus 2 is 3, and then please at 6.
Wait, that's what I was saying.
15, 16.
Wait, I don't.
I don't understand.
Oh, I get.
1 plus 2 is 3.
Oh!
That's what I was
cool.
saying.
I never see that one. Wait,
Oh my
do you guys see what he's doing?
Wait, he breaks the whole and explain it again.
That's cool. I actually didn't. This is one I hadn't seen before.
What? Mr.
Oh, yeah.
Link,
See, Mr. Guzman's gonna take my job.
So 1 plus 2 is 3. He's at 6. He's at 10.
All of what? Oh, all of them were that way before? Yeah.
1 plus 2 plus 3.
1 plus 2 is 3. 1 plus 2 plus 3 equals 6. 1 plus 2 plus 3 plus 4 equals 10. 1 plus 2 plus 3 plus 4 plus 5 equals 15.
So, what is the sum of numbers 1 through 12, real quick? 78.
Yeah, 3.
Jessica, how do you do that?
I just looked at
Yeah. That's cool.
Yeah, I did not ever know.
That could, where's a marker? That could actually work in any row. 1 plus 3 is 4, 1 plus 3 plus 6 is 10, 1 plus 3 plus 6 plus 10 is 20.
Whoa!
I know, this triangle is cool. What was that, North Central students? Oh, like the number in the
Just
nth
ignore him.
row, the rth number is like the combination of n with r. Yeah, thank you. I didn't expect any to actually know that. You probably haven't learned that much probability in combinations yet. That's something you'll notice in college. Alright, now, let's test how much you guys really know. Turn the page. Without turning the page back.
Crystal.
Without looking at this triangle, you're going to create the first 8 rows.
When you read.
What am I reading?
Now, you don't need to draw all those little honeycombs. You can just draw the numbers. You can just draw like 1, 1, 1, and then go from there. And I started it off for you. So, and just to be clear, the 1 by itself is row 0. So you're going to row 8. Hold on, let me cut this. Did we get this caramel? Is it still back there?
No, the mouse took it.
The mouse took it good. Yes.
December?
No, you will.
It goes like
That means the slope.
just got the tip.
No, not you, but you circle. Oh my God. You can ask students who've had it.
I don't know, don't ask me.
Wait, you said it. What's preparing for that? Not because G is that's why G is because G prime is and G prime is like is the derivative of G. It's the slope. So G of x is D. If G prime is negative, the slope is negative.
I'm not lying.
Without looking back.
Can you guys write a song about sing for us? You know the singing, what about like Pascal triangle slide? You get a high five. Alright, 1, 1, then you know it's going to be 1 on the outside, adds 2. moving so fast? How do you create all these numbers? Yeah, 1 plus 6 is 7. 6 plus 15, 21. 15 plus 20, 30. Alright, next row. It's going to start with a 1. 1 plus 7 is 8. 7 plus 8, 21 is 28. 21 plus 35 is 56. That's how I'm doing this.
So technically, you want for 8.
Yeah.
Let's do it.
Alright, you can spend the whole class, just keep filling out your page. I'm going to just do other stuff. But you can keep going on to infinity. I'll be impressed if you follow suit. Don't, Sophia, don't mess with them like that. That was Sophia.
No.
Sophia Ortez.
No.
If you want to find her at prom or senior signing day.
She still needs a date.
Alright. Please don't take this guy. Don't take this guy. Yeah.
At Daniel Paredes. 713-832. I'll send you that by
Alright.
Daniel Paredes.
Gerardo 14.
Again, bring your attention back up here. So this is the triangle. Who is able to make this without looking at the page before? No?
Well, I know he's going.
So I mean, like it's pretty quick, right? The next row you just add. It would just be a 1 here, and you add the 2 numbers above. 1 and 8, you get 9. 8 and 28, you get 36. All right, and now we're gonna see one of the useful applications of Pascal's triangle. And you'll see it in a moment. It's gonna look like we're gonna do something else, but trust me, it'll connect back. The something else we're gonna start doing is taking a plus b to different powers. So you're gonna find what a plus b squared is. You might know that off the top of your head already. Or maybe you just do not say it's a squared plus b squared. You might just use the box method. Then you're going to find a plus b cubed, something you probably don't know off the top of your head. And you're going to keep going from there. Alright? And there's a pattern. There is a pattern. Once you do a few, you might notice it.
It's not moisture.
Did work, Carlos. Yeah. They're going to be watching these videos. Yeah, but I mean, they're watching these videos this year. It's not for next year.
This year?
Okay. They just wanted to watch the best calculus teacher in the world.
What school is this?
Can you cut out the part where you
I think they're watching the movie now. And then they'll
And then we'll watch it.
Mama.
Is that about calculus?
I thought you were just talking to me. Some of my students just call me Mama. They know.
Rudy.
Which movie?
Standing Deliver. It's about a calculus teacher in LA. It's just like a feel-good movie that comes into this rundown school or it's not great. No.
Sorry, what are you doing back
Yeah, like
there?
turns the calculus program around. It's great. I watch it after my calculus. Yeah. All right. What are we doing here? Noemi, what's the first one? Right, I'm gonna write it this way. Just because that. You'll see what. All right, and then who's got the cubed one? Mario.
A cubed plus 3a squared b plus 3ab squared plus b.
Yeah. And then to find a plus b to the fourth, you got to do the box. A super big box. And I think you did it. You just combined both terms. Do you see how this is the same as what Mario said? Not the same because that's b squared a and that's ba squared. So you can't have that. Yeah. B squared a, b squared. Those are the ones you got. So it's not going to be 3.
Yeah.
It's going to be 4. So you're noticing something. It's partly right. Well, I should say partly right. It's not right. But this part of it works. But it's more than just these numbers. Because you have 3 terms here, you have 4 terms. So you're going to have, what's the term you're going to have? 8. Right, 8, but it's not going to be a cubed b squared. Notice, this power is 4, 3 and 1 adds up to 4, and 1 and 3 adds up to 20. So the real term is going to be a squared b squared.
¿Qué?
Ahora.
Mamá.
Wait, this is 3.
Ternura.
Yeah. Yeah, but it's not just adding 1, there's something else that's happening. Guys, for the a plus b to the 4th, like actually do the box because a lot of people are trying to notice a pattern one step too early. They're trying to say it's a to the 4th plus 4a cubed b plus 4ab cubed plus b to the 4th. That's not what a plus b to the 4th is.
It'll be.
So use the box and you'll notice it. Do the box. Just do this one and then hopefully you'll notice it better.
Oh, Pascal.
And I have one last caramel for anyone who can tell me what the pattern is here. I don't know. It's a French dude. Pascal. He is 16 stuff. I feel like he is like 6. Pascal, no, he makes an. I don't know what it is. Pascal's wager. He's a because I've read about something else he did. He makes this argument. It's kind of okay. It's unrelated, but so he makes an argument that you should believe in God because even if there's a small chance you believe in God, it's like infinite happiness in heaven. So like that small chance of infinite happiness is mathematically right there. It's he goes more in depth. It's kind of a crazy argument. But look up Pascal's wager if you want to read that. Yeah. At home. Well, okay, so now combine all the like terms in here. Right? All like b squared, a squared, b squared, a. That's it.
Samantha's looking for
The
a
AP Calc says it matters if she didn't explain like that. She doesn't have to simplify it.
That's why I just
All right.
like that.
Smart pants. Yeah, and I mean AP Calc test, yeah, but to see the pattern, you're gonna have to combine the terms.
Yeah, so she's a circle lifesaver.
Everyone in this class is lazy, not want to do the box.
It's a lot.
Oh my goodness. Yeah, you're almost there. Yes. What's the pattern? Look back at Pascal's triangle.
Te la pasas como
No, you backwash, bro.
Okay.
I know.
Alright, this next one. Paolo, what should it be?
A ver, enseña China.
A to the fourth plus 4a cubed times b plus 6a squared times b squared plus 4a times b cubed plus b to the fourth.
Yes, thank you. Because everyone is so lazy, I will do the last one.
Yay.
Hip, hip.
Plus 5a4b.
Now you want to show
You
up.
tell me what's going to come next. Can anyone tell me what's going to come next?
6, 8,
Uh,
no.
7, 8.
9.
So now you want to put
Alright, well you can just keep guessing numbers. Guess one more.
Or ya venado y...
Where has it been all the year?
Because it's 4.
Oh! Oh! That's it.
Yeah, it's just like the.
Alright, to help you notice the pattern, maybe I'll write the coefficients in front of each of
Do
these.
we have offspring?
Right, instead of a squared,
Do we have
you could write that as
offspring?
1 times a squared. B squared 1 times,
More sorry, Christmas.
1 times. Now, look at those numbers. Look at the coefficients. Jonathan, I did all the work for you now. Look at the coefficients.
Just add them.
Yeah, you said.
What do you mean you just add them?
I'm not saying the one on the bottom is like 6 and 4 is
6 and 4 is 10.
10. Both right.
And like 4 and 1 is 5. What does that sound like to you?
Pascal triangle.
Yeah. So what is the connection here? Someone tell me.
There's a clear connection between them.
What is a connection? Nobody's gonna go for it. Let's bring our attention over there.
You just add like 1 plus 2 plus 3. And then like there's always going to be that 1 on the outside.
Yeah. And you could also just look at the numbers in Pascal's triangle. Right, this is, we call the first one row 0, row 1. Guys over here, I do need to stop talking to stop. So we have a plus b squared to the power of 2, so you look at the second row. 1, 2, 1. 1, 2, 1. For a plus b cubed, you look at the third row. 1, 3, 3, 1. A plus b to the fourth. Where do you look? Where do you look?
Fourth row.
The fourth row. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1.
Yeah,
That's
that's the
Alright, I want you guys to answer the question at the bottom. Now, Pascal's triangle can help you for expanding really nasty things. Or, like the a plus b to the 8th. That would be really nasty using the box method. Now you guys can do it pretty quickly. Find what a plus b to the 8th is.
Right there.
Oh, you answered. You ready?
Wait, where's my candy?
I only have one left.
Boy, that's hers. Remember she did the box.
I said for noticing the pattern. They also did the box too.
So she gets no candy.
I only had one, sorry.
Gonna make her try. 3 plus 2 is 5. Nice. Get the calculator.
I can pull up this name calling. I can call on someone to give me the answer here. Yeah, go ahead. Yeah. Hey. That's how we're doing now.
Es horrible. Y todavía sigue roja.
He looks like his dad right now.
Seriously, I do want you to run it.
Again?
No.
It's probably new. Todos los días se trae snacks de la casa.
Okay, so I grew this, but I don't hear this.
I thought it was like multiply times 2, 5 times 2, 10, and then 3 times 2.
Not always, because it's the one above, look, it's 4, 1, 4, 6, 1, 4, 1. Those numbers came from somewhere else. Yeah.
Oh, yeah, that's right.
It comes from the triangle. Right, that's where the 1, 4, 1, 4, 6, 4, 1 comes from. Chelsea, that came from here. This is the 4th row. So for the 8th row, what do I need to do?
28, 72.
For 8 plus b to the 8th, what do I need to do? You look at the 8th row. These are the numbers.
28, 72.
I got it.
All right. Let's see who the lucky person is. Javier, give me the answer.
You got it.
Yes.
I got it.
No.
Yes, sir.
8 plus b to the 8th. What are you working on for a few minutes?
Get it on.
Not an option.
What time is plus 8 times a to the 7b plus
365.
Where are you getting these numbers from? Where do the coefficients come from?
8. Where?
From
that 7th row, right now,
8th row.
8th row. Oh, okay. So what was that? Alright, so 28. Times a to the power of
That 6.
6, yeah. B to the power of b squared.
That.
Yeah. Plus
Why is it b squared? The b powers are increasing by 1 each time. A powers are going down by 1. Sophia. Alright, so 28 a to the 6b squared plus
56. A to the power of 5. B to the power of 3.
yes.
Oh, plus 7.
Alright, I'll take it from here. This is getting painful. Alright, 78 to the 4th plus b to the 4th plus 56 a cubed b to the 5th. Plus 8a b to the 7th plus b to the 8th. So guys, make sure you get this down. Who got this out? Who had this? Nice.
Instead of volume. I was hoping que no estaba eso en el test, sino fue la first question. That's easy.
Alright. I want to use this for explaining the power rule. Back in August, or no, it wasn't August. October maybe we learned the power rule. Maybe it's September, I can't remember. We learned the power rule and for some reason you just believed me. For some reason you just believed it's true and I never even told you why. I never convinced you why it's true. For example, if I asked you to find the derivative of x to the 6th, it would be what?
6x.
Right, and you're telling me that, but why? You can't be convinced why. I just told you, yeah, but why do you know that works? Why does that work? Why does that work? Let's see why it works. Now we can use our Pascal's triangle to actually prove that this works. So I think it's pretty cool to see that how this actually works in action. So turn the page. Alright, so back when we started derivatives, we learned the derivative as this expression, limit as h approaches 0 of f of x plus h minus f of x over h. Right? Remember, you might have blocked this off from your memory, but this was August. And we went through that painful process. Remember, we were finding limits with the painful process of doing x plus h squared, x plus h cubed. This is what the pre-cal students are doing now. They're going through all that pain of actually using this expression to find the derivatives instead of using all the derivative rules. Right? But now I want to use this expression to find the derivative of f prime of x when f of x is x to the 6th. So you're just using limit as f of x plus h minus f of x over h. Gerardo, what does that mean, f of x plus h? What does that mean to do? F of x plus h, what does that mean? What does that mean? Or how do we find that? How so? You can't distribute the f. That's not a legal move because it's not f times x plus h, it's f of. It's like a function of x plus h. But what's f of x? No, we're not taking derivative. I'm just saying find f of x plus h. What's f of x? What's f of x? This is just in the problem.
X to the power.
X to the power 6. That's all it is. F of x is x to the power 6. not x to the power of 6, because we're doing f of x plus h. X plus h is the input.
Oh, x plus h to the power of 6.
X plus h to the power of 6. F of x. Right? Cindy, how are we going to find x plus h to the 6th? How are we going to find this? Pass on Lillian, how are we going to find x plus h to the 6th? Well, okay, we could, but you'd have to use your power rule. I want to go we're doing the painful process just once. You want to do the box 6 times? You can go for it. Or we can use this. Ishmael, how can we use this?
Go to row 6.
Row 6. Yeah? Do it. Find x plus h to the 6. Solve this out. You give up? Huh? X plus h to the power of 6.
We can use the past, no?
Well, not this, but it's like we're doing this on the page before. It's not x plus h, here is a plus b. And we did a plus b to the 8. How do we do that? Same thing, but now with not a and b, x and h.
It's going to be 15x plus b.
Lillian, I need you to actually give me one. Okay. Need more than that.
Okay, x to the 7.
15, wait, 15.
X to the 3.
No, wait, hold on, but you need the 6 first. Use the 6. That's the exponent. Then it'll be 6 times this. This is like the 1 times x to the 6. X to the 6th, 1 times that, plus 6 of the next number. You decrease this power by 1 x 5th, then you add in the h. Oh, 6x to the 5th times h. Yeah.
Actually, no, 15.
You know what I mean? Alright, I'll be picking a victim in a second. Jennifer. Alright, tell me what x plus h to the 6th is. Oh, Jessica.
Oh, man, no.
6. X power of 6.
Plus 6x to the power of 5h plus 15x to the power of 4h squared plus 20x to the power of 3h3
Yep.
15x squared h to the power of 4 plus 6x to the power of 5.
Yep. This is f of x plus h.
We got that on tape.
Minus x to the 6th. Right? Minus f of x. Ooh, that's a crazy looking fraction. That is a crazy looking fraction. There is one thing we can do to clean this up a little bit.
Or combine
Not
like
yet
terms.
because, not quite yet, because there's still some terms without an H in them.
That's what you combine
What like terms are there?
X to the power 6 and minus
Oh,
X to the power 6 minus x to the power 6. Yeah. Gerardo is absolutely right. These two cancel out. X to the 6 and minus x to the 6. So you're going to be left with all this stuff. 6x to the 5th h plus 15h to the 4th, all that stuff. Now there's an h in every term. Now we can take out the h. Now I can turn this in. I'll bring it down here. Take out the h. If I take out the h on top, what am I left with? 6x to the 5th plus six h to the 4th plus h to the 5th. Now what? Cancel out the h's. And look what we're left with now. How are we going to evaluate that? Plug in 0 for
H.
h. Alright, we cancel out our h's. We're left with this. And now we can plug in 0 for h. But look, take a second. Plug that in. You'll see it. Gonzalo, one sec. 6x to the 5th plus what happens to this? 0. 0. And what do we get? What you would have gotten in 1 second with the power rule, but you got this now using the real definition of derivatives. Like you could do this for any power rule problem, and Pascal's triangle would show how you use power rule. All right, tomorrow we're gonna do some coloring. Yay! No, but you do need to bring this packet. Keep this packet with you. Binder Central.